20-1s. At this point, you have already become a genius and have had an excellent reminder of how to factor. I will talk a little bit about some extensions in the next day, but there is, again, confidence you've got to about factoring before you've got to this. So I get to slide on down to the bottom part, which is starting to examine factoring quadratic equations in the purpose of, or for the reason of, solving quadratic equations. So to understand why we're doing this, we need to know there is something called the zero product property. You do not need to know that name, but it is going to allow us to actually do something with quadratic equations and factoring. So the entire lesson for 4.2 is going to focus on the fundamental idea that if you have a product, let's just say A times B, that equals 0, that if A or B was 0, not even both, if one of them was 0, then the whole thing is 0. Imagine if I said 0 times, and I said A is a 0. 0 times B, what would you end up with? I don't care if B is a 50 or 1,000 or a negative 60. 0 times anything is 0. What if I said A times a value for B this time? What if I said B was 0? And I don't care if A is 1,000, a million, a billion, negative 100. 0 for the B, 0 times anything is 0. So if A is 0 or B is 0, it's always true. And this is the zero product property, only when it equals 0. Pause for dramatic effect. So how does this work for quadratic equations? Well, we do have in an already factored form two binomials in a product that equals 0. Imagine for a moment I plugged, and I'm going to be selective, I choose x equals 2 to plug into here. What would happen if x equals 2? We would have a 2 minus 2 times a 2 minus a 5. I really don't care what it is. 2 minus 5 is technically negative 3, but to the point where I don't care at all, and I'm going to put a number sign. No, it's just a number, because I'm so confident that 0 times whatever number that was, negative 3, it's going to result in a 0. So if x is equal to 2, the whole thing will work out, and we'll get a 0. Take a guess of what the other possible number might be. 5 minus 5. If we say 5 minus 2 times 5 minus 5, will we get a 0? Well, 5 minus 2 is a 3. I'll call it a 3 this time. And a 5 minus a 5 is a 0. And in fact, that is true. So if either binomial equals 0, it's a win. We can say that there will be two answers for this question if x is 2 and if x is 5. So to make this a little less intensive for our brains, what we get to do is make a little mini equation for each factor and say, what if the first binomial equaled 0? What if the second binomial equaled 0? Two mini equations. Solve for x separately. If you add the 3 to the right side and divide both sides by 2, we'd have 3 halves. There is an x-intercept. There is a root. There is a 0. So if you graph this parabola, this quadratic function, you would notice this would be an x-intercept. For the one on the right, x is negative 1. For the far right example, this is a product of 3 things, and the zero product property would work if this was like a 3x or a 5x, but because this is a 3 and not a variable, it's not going to help give us another x-intercept. Remember, there can only be 2 for parabolas. And I mean, if you think about it, if you said, when does 3 equal 0, when does x minus 3 equal 0, and when does 4x plus 3 equal 0, there's a lot of logic that would say 3 is never 0, so really, that doesn't really do anything for us anyways. But you can add a 3 to the right side, there's an x-intercept, and again, you're going to get good at these. Subtract a 3 over, divide both sides by 4, and you're not going to rush as you do these, but in a video we'll make this a little bit concise. So this is what it looks like when it's already factored. You're not going to have questions that are already factored most of the time. So as we get to true examples where it asks to determine the roots, the zeros, the x-intercepts, our first step is to factor. Now, whether you're using decomposition or lucky, you need to get good at this. So if I were to do lucky, I would say x times x makes x squared. I would say probably a 7 and a 3. The positive would have to go on the 7 and negative on the 3. Do a check. 7x, negative 3x. Add them together, it makes a 4x. Awesome. Our factors are x plus 7 by x minus 3. Our answers are negative 7, positive 3. Those are the x-intercepts, the zeros, the roots. So factor, independently get your solutions. Again, we'll do one with decomposition, and that will be all that it'll show for actually factoring and how to factor. So if you're doing decomposition, you'll ask what multiplies to a negative 12 and what adds to a negative 1, and that is a negative 4 and a positive 3. So we decompose this to a negative 4x and a positive 3x, and we look at our first and second pairs and factor out what we can. 2x comes out of the first, a 3 comes out of the second, and we see a matching x minus 2 factor, leaving us with a 2x plus 3 left over. And this is your factored form, giving us two solutions, x equals 2, and when is 2x plus 3 equal to 0? You're not going to be able to shortcut it as quickly at this point, but it will be a subtract a 3 over, divide both sides by 2. And those are your two x-intercepts. And again, if you do like lucky, I kind of prefer lucky. It can be a little bit quick. Factors of 2x squared. And again, I could either write a 6 and a 1 or a 3 and a 2. And I kind of know that a 3 and a 2 is nice because there's a 2 times a 2 and a 3 times a 1. So there's a 4 and a 3 that are connecting. And if I put the negative on the 2, because I know that this has to be negative, I can say there's a negative 4x, positive 3x, and that will combine to make our negative x. So 2x plus 3, 2x plus 3. X minus 2, x minus 2. And you'd end up with the same factors, the same result. Now again, some unique cases you're going to come across: 2x squared minus 6x, solved by factoring. Not a difference of squares, not a lucky or decomp question, a GCF question. 2x comes out, x minus 3 is 0. When is 2x going to equal 0? When is x minus 3 going to equal 0? And in this case, 2 times 0 is 0. Or divide both sides by 2, and 0 divided by 2 is 0. Add a 3 over to the right side, and those are the two possible answers. So you're going to get caught on some of the trickier examples like this, but we'll be able to get there with a bit of practice. And lastly, we've got a couple questions which maybe could be a little bit unique, but the one on the left is a perfect square trinomial that we would have seen in our completing the square work, x minus 5, x minus 5, and I'm going to sort of trust that you'll take a little bit of time in your practice to say there is one real root or two equal real roots. I could technically say x equals 5 and x equals 5, but it's kind of the same thing. This is a difference of squares. X minus 4, x plus 4 is 0, and so we can write this positive 4 and negative 4 at once if we really, really wanted. And for the last one, again, this is going to take a little bit of time for you to get good at, but a 3x plus 4 and an x minus 2, giving us our two solutions, a negative 4/3 and a positive 2. It might be worth trying to do some of these factoring questions yourself, but this is what factoring can do to solve quadratic equations. We're going to save the rest of it for next day, but for now, it might be worth trying a little bit of practice for some basic factoring examples to see if you can factor and solve. Good luck!